So this is the second part of chapter 9.3. So after you figure out the percent composition, you can then determine the empirical formula. So once again, this is kind of a rolling topic. You have to understand percent composition in order to find empirical formula. For right now, we're splitting the problems up, but eventually you will have one big rolling problem. So first off, what is the empirical formula? Basically, it shows elements in a compound in their smallest whole number ratio. So whole numbers meaning 1, 2, 3, 4, 5, and the smallest number possible. And those are going to be the subscripts. You determine the empirical formula, as I said before, by using your percent composition information. So just for example, an empirical formula could be CH2, where C1, H2 are the smallest whole number representations. However, the actual molecular formula, which we'll get to next, the actual formula could be a multiple of that. So if you take the empirical formula CH2 and you multiply it by 2, you get C2H4. If you take the empirical formula and you multiply it by 3, you get C3H6. So you take the empirical formula and you have a multiplier to determine the molecular formula, which will come next. So just a reminder, you're going to have to convert from grams to moles. It's not stoichiometry. You're not going from the one element to a different element. You're going from one element in grams to the same element in moles. So 1 mole on top always is a constant divided by the molar mass of that element. Multiply all that by the given amount of grams I give you. As I said before, in percent composition, 2 decimals for everything if you can help it. Do not overround. The other thing you have to consider is your sample size is going to be 100 grams. So if you have 45%, that's 45 out of 100. We're going to take the percent sign and change it to grams because 45% of 100 is 45. So the percent sign and the grams is going to go hands in hand. So the percent composition will then equal the number of grams to start this out. So first example, find the empirical formula if a compound is made up of 32.8% chromium and 67.2% chlorine. So as I just said, assume that the sample size is 100. So we're going to take 32.8% of chromium and make it into 32.8 grams of chromium. And we're going to take 67.2% chlorine and make it into 67.2 grams of chlorine because it's out of 100. So the first step is to convert each to moles. So you take the amount given to you in the problem or that you solved for using percent comp. 1 mole is always on top. And then the molar mass the atomic mass of this element from your periodic table. Chromium is very, very close to 52. You do need units, but labels are not necessary because this is all chromium. But if you want to include them, it cannot hurt. So I take 32.8 divided by 52, and I get 0.63 moles of chromium. I start with my given amount of chlorine. 1 mole is a constant. The molar mass, I keep saying molar mass, the atomic mass of chlorine from the periodic table is 35.45. And that comes out to be about 1.9 moles of chlorine. Okay, so that is taking the percent composition numbers, changing them into grams and then to moles. So the next step is to then use the numbers you just solved for, these two, and use that to make a ratio. So we have, once again, chromium and chlorine. I just like to keep them separate and organized. So I'm taking the number I solved for. Okay, so that's just given the 2 that I underlined. And you always want to divide by the lesser of the 2, or the lesser of the ones you're comparing. So I'm going to divide this. It's not going to let me write. There we go. There's decimal there. And divide this by the same thing, the lesser of the 2. Okay, and I get about 1. Well, I get exactly 1. And let me check my math here. 1.9 divided by 0.63, I get 3.015. So I can say just 3. So it's very, very, very close to that whole number. You can use it. Okay, so now I'm saying that there's going to be 1 chromium and 3 chlorine. So my empirical formula is Cr1, which we don't write, Cl3. And we're done. All right, let's try another one. Find the empirical formula if a compound is made up of 40% carbon, 6.71% hydrogen, and 53.3% oxygen. Once again, change the percent sign to a gram because it's out of 100 grams. And then do the same thing we just did. So 40 grams of carbon times 1 mole divided by the atomic mass of carbon. Do not overround those. And I get 3.33 for hydrogen, 6.71 times 1 mole divided by the atomic mass of hydrogen. And then oxygen. If you want to round oxygen to 16, you can, since it is so close. But for hydrogen, I would still use 1.01. I just don't really like to round these just to be more precise. If you want to use all the decimals that are given to you on the periodic table, that's even better. Okay, so the second is to take my numbers and divide by the smallest. So for carbon, I had 3.33. For hydrogen, I had 6.64. And for oxygen, I had 3.33. Divided by the smallest number out of all of them, which is 3.33. Okay. Now I obviously get 1 for this. For this one, I get 1.99, which is extremely close to 2. So I'm going to go, I guess I should say about 2, and then 1. Those are my ratios. So now I just put them in the order given me. Carbon came first. Its ratio is 1. Hydrogen came second. Its ratio is 2, so that becomes a subscript. And then oxygen came third with a 1. So CH2O is my empirical formula. All right. If you want to try this one, I'll give you the answer. See if you can get it. I do want to do one more because there is something tricky, so don't stop watching. But if you want to try this one, it's the same we've been doing. The answer should be AlCl3O12. So see if you get that for that one. Try it out. Okay, this last example is a tricky one. So it says, find the empirical formula if a compound is made up of 81.7% carbon and 18.3% hydrogen. So once again, I'm changing that to gram. Step 1 is to go from grams to moles. Okay, so that's step 1. So these are in moles now. I divide by the lowest of the numbers between the two. Obviously for this one, I get 1. For this one, I get 2.66. Now here's the problem. This is when it gets tricky. 2.66, I know we normally round up, but it's not close enough to round up. Okay, so you have to figure out what times this is going to give you a very close to a whole number. So let's try 2.66 times 2. That would give us 5.32. That didn't really help us. This is still kind of in the middle. So keep going up. 2.66 times 3. That gives us 7.98. 7.98 is very close to 8. So we can use 3 times that. Right? But you also have to do it to that side, this side then. So once again, when I did my division up here, I got 2.66. You cannot closely round that down or up. It's kind of in the middle. Because of that, I had to figure out what times of this will give me very close to a whole number. I took a times 2, I got 5.32. That's still in the middle. That doesn't help me. I backtracked. I took this times 3. That gave me 7.98. 7.98 is very close to 8. So I can use times 3 to get my ratio. But you also have to do it to this side. So 1 times 3 is going to be, whoops, got ahead of myself. 1 times 3 is going to be 3. And we said 2.66 times 3 gives us 8. So those are actually going to be the numbers you use in your ratio. So it's going to be carbon 3, hydrogen 8. So that's the only tricky point is if you get something here that's not very, very close to rounding up or down, you have to multiply. So if it's not 2.0 something, or if it's not 1.9 something, or 0.9 something, I should say, you can't round it up. You can't round it down. And that's it. Empirical formula. Next up is molecular.